Good afternoon, everyone. It's my pleasure to be here to present to you the State of Lake Huron's report on sea lamprey control. We do have some annual reports for each of our lakes of sea lamprey control out on the table, so be sure to grab one on your way out if you haven't already. All right, today I will talk to you about our fish community objectives. I will begin with the status of sea lampreys and looking back at the previous reporting period compared to the one currently. And then I'll review each of the program areas, talk about the highlights and some new things that have occurred. And then I'll move on into the St. Mary's River and then summarize with our plans for 2019. So actions by the control agents are guided by specific goals identified in the fish community objectives for Lake Huron, and they are here. They are to reduce sea lamprey abundance to allow the achievement of other fish community objectives, and also to obtain 75% reduction in parasitic sea lampreys by the year 2000 and 90% reduction by 2010. So using the adult abundance as an indicator of parasitic abundance, the 2000 goal was achieved 3 times in 94, 98, and 99. However, the 2010 goal was not achieved by 2010, but it was achieved in more recent years, beginning in 2015. So here we have the Lake Huron suppression targets. The adult sea lamprey abundance index of 36,000, and a marking rate less than 5 marks per 100 large lake trout. So beginning with the sea lamprey abundance index, we have the time series here. And as you can see on the red line, that's the target of 36,000. And in the reporting period, you can see starting in about 2013, we saw a very significant decline in the abundance of adults in Lake Huron. And in 2015, it dropped below the target, and then slowly has increased to slightly above target. Currently in 2018, the adult abundance index was at 39,000 adults. Moving on to the lake trout marking rate. You have the target of 5 marks per 100 fish. And similar to the adult abundance index, we saw that decline in marking rates. And then it was down to below the target at 3.9 marks per 100 fish, and has since then increased. And currently in 2018, we have 8.6 marks per 100 fish. So the status report for the adult index is generated by estimates that come from the adult index trapping network. And we have 6 traps that are used in the index network for Lake Huron, and those are listed here. The 2 that are marked with an asterisk, the Sheboygan and the St. Mary's River, are the largest contributors to the trap catch. In 2018, there was a total of 21,710 adults captured at these 6 index sites. And again, the adult abundance was at 39,178. So one of the highlights that have occurred during the current reporting period of 2011 to the current day is that we had a move from a combination of model predicted and market capture estimates to an adult index. And that began in 2015 using a modified Schaefer method. Last year in 2018, that method was changed to a Peterson method of estimation. Since 2018, we have also gone back and ensured that the estimates were up to date with this new method. So in northern Lake Huron, the Ontario Ministry of Natural Resources and Forestry and commercial fishers collect data on parasitic phase lampreys and provide that to the DFO. And here you'll see a time series of the data in juvenile sea lampreys per kilometer gillnet per night. During the current reporting period, we've seen a decline in the CPUE with a slight increase in more recent years. So moving on to larval assessment. Larval assessment directs and evaluates control efforts. They do this by conducting surveys to detect new populations, to determine in-stream geographic distribution, ranking streams for treatments, and also to determine post-treatment effectiveness. So in 2018, field staff conducted surveys on 93 Lake Huron streams in 11 lentic areas. They ranked 10 streams and 3 lentic areas for possible treatment this year, and also delineated the larval distribution within those streams. They assessed 36 previously uninfested streams to determine whether new populations were present, and thankfully no new infestations were discovered last year. They also evaluated the efficacy of the 2017 and 2018 treatments in 18 streams in 1 lentic area. There will be a retreatment of a stream this year based on residuals from the 2018 treatment. They also evaluated the blocking effectiveness of 9 barriers, and they collected over 5,000 larvae for sea lamprey research from the Sheboygan, AuSable, and Saginaw rivers. So it's critical to the suppression of adult lampreys in Lake Huron to suppress the larval abundance of lampreys in the St. Mary's River. We do this primarily by using granular balicide in high-density larval areas. So here's a graph of the time series of the larval population estimate in the St. Mary's River. And here you'll see in 2011, that's the beginning of this reporting period, that there was a sharp decline in the larval population. And I'll go into that in the next graph. Since that time, there's been, it's kind of fluctuated, but pretty much steady until 2017, where we saw a sharp increase in the population estimate. And then for 2018, we have an estimate of 1.1 million larvae in the St. Mary's River. All right, so looking at this one, we're looking at treatment effort and the larval population estimate in the St. Mary's River, so same data that you saw in the previous graph. I'm going to overlay the treatment effort here. So prior to any treatments in the St. Mary's River, we had a population estimate of 5.2 million larvae. In 1997, sterile male release technique was part of the management of the St. Mary's River. And then we had a large-scale treatment with granular balicide in over 700 hectares of high larval density areas in St. Mary's. Immediately after that, we had supplemental, or not supplemental, but annual treatments of granular balicide treatments of those high density areas in 100 plus hectares in the river. So there you see that the population is pretty much been stable over that time period. Then in 2010 and in 2011, we had large-scale treatments of over 800 hectares of the St. Mary's River treated consecutively. And there you'll see a dramatic decline in the larval population. 2012 marked the last year of the sterile male release technique. And since that time, we have increased our amount of control in the St. Mary's River with the granular balicide applications, up to 300 plus hectares a year. And again, currently we're at 1.1 million larvae in the St. Mary's River. Some other studies that are conducted in the St. Mary's is looking at egg viability. So the sterile male release technique was eliminated from the program as a management tool in 2012. So prior to that, and continuing from that time, egg viability has been looked at, and during the sterile male release technique years, 32% of the eggs were viable. Post-sterile male release, they're up to 65% viable. And I just received the data for 2018. The 2018 data point for percent viable eggs is at 72%. So out-migrating juveniles are also assessed from the St. Mary's River. That's done every October and November, where pike nets are placed off of the Coast Guard buoys. And the data that's collected is shown here with the juvenile sea lampreys per net day. During the reporting period, we have seen a very low number starting out around 2012 and then just slowly increasing, and the 2018 data point was lower than last year. So lampricide control is the other program area. This lampricide control, they apply lampricides to streams and lentic areas to control larval populations. The objectives to that are to kill as many larval sea lampreys as possible by maintaining minimum lethal concentrations throughout the entire infested length for at least 9 hours. To also minimize non-target mortality, and to minimize the cost and the amount of the lampricide used. So some highlights for lampricide control within the reporting period. There have been many improvements to the treatments by enhancing many different areas. The first one being optimizing the timing, taking advantage of stream flows, whether it's in the spring or the fall, or optimizing timing when a stream needs to have a lower pH or a more predictable pH, would be earlier in the spring versus in the fall. Applying lampricides to more backwater areas, secondary treatments, rivulets, covering as much infested area as possible, or blocking areas for sea lamprey larvae to escape into. We've also increased our number of lentic treatments, and I know Matt talked about that in his talk. We've also taken advantage of geographic efficiencies, where we might have a small tributary that's infested with sea lampreys that did not rank, but it's very close geographically to a larger system, and if staff are available, lampricides available, then they can treat that. So we schedule that early on in case there's time and people available. We also receive assistance from other program areas. So we have people from the adult assessment, larval assessment, risk assessment teams that if they have other duties that are lower priority, they can put those off and they can help out on treatments. So we've been able to try to schedule that as much as possible. However, sometimes there is a need last minute, and we've been very fortunate to have people step up. And we've also had targeted treatments, so that within the reporting period, that is something new for lampricide control. The Great Lakes Fishery Commission has allocated resources to increase stream treatments, and I'll go through that in a bit here. So the targeted treatment strategies, looking specifically at Lake Huron for 2011 to 2014, the red circles are the first targeted treatment strategy that affected Lake Huron sea lamprey abundance. So that was focused on the St. Mary's River and the North Channel area. 2012 and 2013 saw an expansion of this strategy from the North Channel area out into other infested streams in Lake Huron, as well as some in Lake Michigan. And 2013 and 2014 focused on northern Lakes Huron and Michigan streams. And the yellow dots are Balaside lentic treatments. The 2015 treatments are shown here, as well as the Balaside lentic areas. 2016 was the year for Lake Superior to receive targeted treatments. However, we still had a number of treatments, 28 stream treatments in Lake Huron, and 6 lentic areas were treated. 2017 was the year for Lake Michigan, and for that year, Lake Huron received 16 stream treatments and 2 lentic treatments, including 346 hectares of the St. Mary's River. 2018 was our year for Lake Huron, so we treated quite a number of streams. 34 stream treatments were regularly scheduled, 18 additional treatments were part of the targeted treatment strategy, and 5 Balaside treatments were conducted, along with 336 hectares of the St. Mary's River. So some highlights from this last year. The treatment schedule changed a number of times due to changing water stream conditions, and I know quite a few of you here in the room, Michigan DNR especially, great communication with everyone, so we were able to adjust the schedule accordingly, and can't thank you enough for that. The Tittabawassee River was treated for the first time. It's quite a big river, and so the Ludington team, they did a great job on working on that, collecting all the preliminary treatment data, and took quite a few hands. There were also some deferred treatments. Those include the Upper Black Mallard and the Shebashakong due to low water, and the Pine River, which is the Saginaw River tributary, due to hydrodam putting out inconsistent flows, so there was no way we could start a treatment with that. We need some stability. And the lentic area of the Echo River, the Root, Garden, and Mississauga rivers were deferred due to First Nation concerns. So our alternative control are sea lamprey barriers, alternative to the lampricides, that is. In 2018, there were 17 barriers we have 17 barriers that block spawning phase sea lampreys. 13 are purpose-built, and 4 were built for other reasons but are modified to block. There was routine maintenance that was performed on 11 barriers, and field staff inspected 5 of these to assess blockage and also to improve the information in the barrier inventory and project selection database. Consultation with partner agencies on barrier removal proposals were at 24 sites in 8 streams, and repairs and improvements on the Echo River barrier occurred. So one of the major highlights for barriers is that Denny's Dam on the Saugeen River was completed in partnership with the Great Lakes Fishery Commission and the Saugeen Ojibwa Nation. The Nottawasaga-Nicholson Dam spillway refurbishment was completed, and there were fish community assessment surveys that were conducted on both of these streams. So there are potential alternative controls that are primarily in research stage, looking at juvenile trapping that continues attractants and pheromones, repellents, nest destruction, and also looking at new trapping designs. The eel ladder style trap was tested in the Yakyak and the Sheboygan rivers, and that has now been included as part of the trapping system in the Sheboygan. And what that does is it's a sorting trap where sea lampreys basically sort themselves from the other fish that are captured in the trap by means of an eel ladder. I wish I had a picture of that. All right, so moving on into our 2019 program plans. For barriers, they will continue to operate and maintain 13 sea lamprey barriers. They'll conduct site visits to inspect the structures, and the Echo River trap will be replaced with a new one. So for sea lamprey assessment, larval assessment plan to survey over 100 streams, 20 lentic areas, and also to continue assessments on the St. Mary's River larval population. The juvenile assessments, they'll conduct standardized FICNet assessments on the St. Mary's River and continue work to assess the feeding juveniles and marking on lake trout with other agencies in the commercial fishers. Adult assessment plans on operating traps and conducting mark recapture on the 6 index streams, and also to perform the ag viability studies in the St. Mary's River. For 2019, Lamprey treatments will occur or on schedule to be treated for 14 streams and 3 balicide lentic areas, along with 313 hectares of the St. Mary's River. All right, so we have some strategies to meet our fish community objectives, and these have been identified in the Lake Huron Sea Lamprey Management Plan. This is to increase lamprey control. We have supported this by increasing control with larval assessment effort. We have gone to targeted treatments where we have resources allocated towards those stream treatments specifically, and also to decrease spawner abundance. We want to see some advancement in some alternative controls, continue with the barriers, continued involvement in barrier removal decisions, and also looking to new trap technologies. And we'd like to see developed an improved metric to measure program success, looking at fish community wounding. So some of the challenges that we face and continue to face are the increased number of proposals to remove dams to improve connectivity, fish passage, and safety concerns. And the other challenge that I mentioned earlier are the Mississauga and Garden River treatments have not been able to occur for 5 years, and the effects of this, of not treating those streams, are estimated to have the greatest potential for sea lamprey production in Lake Huron, with some major effects to the Lake Huron fish communities. So here you'll see the 3 major producers of larval sea lampreys to Lake Huron. They are the St. Mary's, the Garden, and the Mississauga. So over half of the lake-wide larval population is estimated from these 3 rivers combined. In summary, going back to the status graphs, the adult abundance has decreased. The 2018 mark is slightly above target. The marks per 100 fish has decreased within the reporting period, and also the 2018 data point is above target. I'd like to acknowledge and thank many of the people that helped me out with the data. There were staff from the DFO and Fish and Wildlife Service, along with Paul Sullivan, who is now retired, and Fraser Neve. And with that, I'll take any questions.